Welcome back to The Clean Truth by Roobi. This is our deep dive, and today we're tackling a really big subject, the clean revolution, why laundry sheets are changing everything. Our mission today is, well, it's all about understanding how these new super concentrated cleaning formats, like the laundry sheets popping up everywhere, are really shaking up the whole laundry game. We're talking about cutting down plastic waste, slashing carbon emissions, and honestly just making things simpler and way more sustainable. We want to give you the hard data, the real info, not just greenwashing claims. And we're grounding this whole chat in some solid scientific research, specifically a comparative life cycle assessment, an LCA, as the experts call it, published by Springer. It really digs into the nitty-gritty, comparing traditional detergents to these newer, more eco-friendly options.
Exactly. And that's our job today, right? To pull out the clear, actionable stuff from this pretty dense scientific paper. We're breaking down how they compared everything systematically to see not just if these new ways are cleaner, but why. And, maybe more importantly, where some hidden environmental costs might still be lurking. But we're keeping it positive because the data really does show cleaning can be cleaner. Let's dive into the clean revolution.
Okay, so like any good revolution, we need to know what we're fighting against. What's the actual environmental rap sheet on, the traditional stuff, the liquids and powders we all grew up with?
Well, the cost is huge, honestly, and it mainly hits our water. Traditional detergents are often loaded with things like phosphorus, nitrogen compounds, oils, bleach, sometimes even strong acids. When all that washes away, it heavily contributes to something called eutrophication.
Eutrophication. That's basically like over-fertilizing a lake, right? Causes all sorts of problems.
You nailed it. Imagine dumping way too much plant food into a pond. You get these massive algae blooms. Then, when the algae die and decompose, they suck up all the oxygen in the water. It becomes toxic, kills fish, messes up the whole ecosystem. The research points fingers at things like anionic surfactants and elements like sodium. They can change the water's pH too, which is another blow to aquatic life.
So the chemicals themselves are bad news for water. But the study also set a baseline for just how much product we were using, didn't it? Like how inefficient the old way was.
Oh, absolutely. To make a fair comparison, the researchers used the standard method ISO 4-140 and a tool called Recipe 2016 to measure the environmental impact across different categories.
Okay, hold on. Recipe 2016 sounds like something from a kitchen. What does that mean here?
Yeah, it does sound a bit like that. Think of it more like a scientific translator, maybe. Recipe 2016 is a widely used method that helps scientists take raw data, like, say, kilograms of CO2 emitted, and translate it into standardized impact scores. Scores for things like climate change impact or freshwater toxicity. It just ensures everyone's comparing apples to apples when looking at different products or processes. So using that system, they set the baseline for traditional solid detergent, let's call it TD. And get this, to wash a standard 5-kilo load of laundry, you need almost 100 grams, 99.99 grams of TD.
Wow, 100 grams. That's like a big scoop of powder or a pretty hefty chunk of a bar soap just for one wash.
Exactly. That's our starting point. That's the benchmark for environmental inefficiency we're comparing against.
That feels like a lot of stuff for one load. Okay, so now bring in the alternative they looked at. This biomultipurpose liquid detergent, the BLD, this represents those newer concentrated liquids, right? How does it compare to that 100-gram scoop?
The difference is pretty dramatic. For that same 5-kilo load, you only need about half the amount, 49.92 grams of the BLD.
Just under 50 grams. So you've basically cut the amount of product needed per wash almost in half.
Right. Think about that over a year of laundry. You're using half the physical product, half the material, and it scales up. The study calculated that to get the same cleaning power as just 1 liter of this concentrated BLD, you'd need about 2 kilograms of the traditional solid stuff, the TD.
2 kilos of powder versus 1 liter of liquid. That's a huge reduction just in terms of sheer volume and weight. What does that translate to environmentally?
The benefits are pretty clear-cut, according to this research. They set the concentrated liquid's impact as the baseline, like 1.0. Compared to that, the traditional detergents' impacts were up to 10 times higher in most categories they measured.
10 times. Wow. Any specific numbers that jumped out?
Yeah, 2 big ones. The BLD had an 88% lower impact on climate change, and its water consumption impact was 91% lower compared to the solid TD.
Okay, 88% lower climate impact. That's huge. Is that just because you're using less product, or is there something else going on chemically?
It's a bit of both, but the chemistry is really the key driver here. The study pinpointed the main reason for the TD's much higher footprint. It's the raw materials needed for saponification.
Saponification, that's the traditional soap-making process.
Yeah, exactly. Making that solid bar or powder requires reacting oils with sodium hydroxide. And the TD needed 4.5 times more oil source compared to the liquid BLD for this process. That heavy reliance on oil is what really drives up the traditional product's environmental footprint, especially for climate change and resource depletion.
Okay, let's unpack this a bit more. So the concentrated liquid, the BLD, is clearly way better than the old school solid soap. Huge improvement. But here's the thing, even if it's better, it still has an impact, right? Where does that remaining environmental cost come from? We always focus on the plastic bottle.
And that's the crucial question. The researchers did what's called a cradle-to-site assessment. So looking at everything from getting the raw materials out of the ground or factory, right up until the finished detergent leaves the production plant. And for this liquid biodetergent, the BLD, the raw materials in manufacturing stage, accounted for a staggering 91% of the total climate change impact.
91%. Hold on. So you're telling me that the plastic jug I'm holding is only a small part of the problem. Almost all the damage is done before it even gets to me.
That's precisely the insight from this kind of analysis. It really shifts the focus. If you look at the carbon footprint per liter of BLD, about 0.314 kilograms of CO2 equivalent, two things stand out. The biggest chunk, almost 79%, 78.8% to be exact, comes from the main cleaning agent itself, the petrochemical surfactant, in this case fatty alcohol sulfate, and the PET plastic bottle. That contributed about 12.2%.
Wow. Okay, that completely changes how you think about it. The chemical doing the cleaning is the main environmental load, not the container it comes in. What about the water used to make the detergent?
Same story, really. Making 1 liter of this BLD used about 5.4 liters of water in total, from cradle to site. And again, the surfactant production was the biggest water user within that, consuming about 1.6 liters of the 5.4. It just reinforces that the surfactant, where it comes from, how it's made, that's the real hotspot.
Right, so the surfactant is number one, but packaging is still number two at around 12%. What did the study suggest for cleaning up the packaging? We hear a lot about switching plastics or using refills.
They looked into that. They compared the standard PET plastic, that's your typical clear plastic bottle, with HDPE, which is high-density polyethylene. That's often used for milk jugs, detergent bottles, things like that, usually opaque. And they found that using HDPE containers was actually better in most environmental categories compared to PT.
Better how? Specifically, switching to HDPE cut freshwater eutrophication impact by 10%. Remember the over-fertilizing issue? Reduce that. It also lowered the ecotoxicity impact, how harmful it is to aquatic life, by about 8% for both freshwater and marine water. Primarily because HDPE tends to be more durable and generally easier to recycle effectively.
But there's always a catch, isn't there? Did switching to HDPE cause any other problems?
There was a slight trade-off, yeah. The HDPE bottle had a slightly higher carbon footprint, about 7 grams more CO2 equivalent per bottle, and used a tiny bit more water in its production, about 0.6 liters more. But, and this is key, this is where reuse programs come in. The study specifically mentioned how this small downside can be completely wiped out if you reuse the containers. They cited a real campaign, Redimite con el medio ambiente, redeem yourself with the environment. That program got a 36% return rate on HDPE containers for refilling. When you factor that in, the reuse potential of HDPE really helps mitigate that slightly higher initial production impact.
So the material choice matters, but the system around it, like reuse and recycling, matters just as much, maybe more. Exactly. It's the whole picture.
Okay, this leads us to maybe the most interesting part, I think. Trying to replace that petrochemical surfactant, the 79% climate villain, with something bio or plant-based. We tend to just assume plant-based equals better for the planet, but this LCA study, did it find that to be true?
Well, this is where it gets really complex and, frankly, a bit counterintuitive. The researchers tested this exact scenario. They did a sensitivity analysis where they replaced 30% of that main petrochemical surfactant with a common plant-based alternative derived from palm oil.
Right, palm oil is used in tons of products. So swapping out some fossil fuel for palm oil, did it lower the environmental footprint?
Shockingly, no, not really. The new formula actually performed worse in 7 out of the 8 environmental impact categories they measured.
Worse? How is that even possible? You're using a plant instead of petroleum.
The only benefit they saw was an 8% reduction in fossil resource scarcity, which makes sense because they use less fossil fuel. But for everything else, climate change, water use, toxicity, land use, it was generally worse. And the why comes down entirely to the palm oil supply chain itself.
Ah, so it's not the ingredient itself in the bottle, it's how you get the ingredient.
Precisely. Palm oil production, especially in regions like Southeast Asia, is often linked to major deforestation, burning peatlands, habitat destruction, huge impacts on biodiversity and land use. Plus, the farming itself involves fertilizers, which release nitrous oxide, a potent greenhouse gas and wastewater treatment that can release methane. These hidden emissions add up significantly.
So you swap out the emissions from an oil refinery for potentially even worse emissions from unsustainable agriculture and land clearing halfway across the world. It's just shifting the problem.
That's exactly the risk. The study does note that other plant oils, like rapeseed oil, might perform better than palm oil in certain categories like climate change, depending heavily on how and where they're grown. But the big takeaway, and this is crucial for you listening, is that plant-derived doesn't automatically mean green. It's only truly better if the entire agricultural process, the whole supply chain for getting that plant oil, is genuinely sustainable and traceable. We can't just trust the label.
It really puts the responsibility back on the manufacturers, doesn't it? To be transparent about that huge 91% chunk of impact that happens before the product even gets made. Wow. Okay, this has been a really fascinating deep dive into the science. So if we boil it all down, the main conclusion seems clear. Moving to these concentrated formats like the BLD they studied, which is the basis for things like laundry sheets and pods, it does make a massive difference compared to traditional powders and solids. These huge cuts in climate impact, water use, those are real proven wins.
Absolutely. The concentration and the format innovation itself, that delivers fundamental environmental benefits, no question. But the LCA forces us to look deeper. True sustainability means looking at the whole life cycle, especially those raw materials. We can't just blindly swap fossil fuels for something like palm oil without verifying its source. Otherwise, like you said, we're not solving the problem, we're just moving it somewhere else, potentially somewhere even more fragile. So even when we find products that are genuinely better, the journey to a truly clean revolution means we have to demand transparency. We need traceability for every ingredient. It connects what you do in your laundry room directly to things like deforestation policies and ecosystem health on the other side of the planet. You, the consumer, need to start asking, where did this cleaning agent actually come from?
That's a powerful final thought. So next time you're looking at detergents, whether it's liquid, powder, or these new sheets, think beyond the bottle. Think about that 91%. Ask yourself, does this brand tell me where their ingredients come from? Are they transparent about the real footprint? Definitely something to chew on. Until next time, keep demanding that clean truth and traceability.